So by this point, we've talked about direct proportion and inverse proportion. Now, direct proportion and inverse proportion both involved relationships between two variable quantities. Okay, that's very important. They were relating to quantities only. But what if we take things a step further? Sometimes there are more than two quantities being related, and that is today's lesson: joint proportion. So joint proportion relates three quantities. And by definition, we say x is jointly proportional to y and z if x is directly proportional to both y and z. So that's very important. X is directly proportional to both y and z. So another way we could write that would be x over yz is equal to k for some constant k. And we could also view that as x equals k times yz if we just multiply both sides by yz. Now we've seen problems that use direct proportion and inverse proportion, and we've seen some real-life applications. But can you think of an example that uses joint proportion? It's something we see in real life. This one thing really stands out to me, and you might be familiar with it because I actually already covered this on my channel, and I probably should have covered this topic before doing those videos, but if you really want to know, it was D equals RT. And this stands for distance is equal to rate times time. And I'm going to be going over that more in depth in another video. But for now, this is just a little introduction. Now this is an example of joint proportion because we have three quantities being related with each other. We have the distance, the rate, and the time. And in case this doesn't look like this and you're a little confused, I'll just divide both sides by RT to get 1. And I hope that looks more like this. All right, so let's get right into a problem. So our problem states that A is jointly proportional to B and C. If A equals 5 when B equals 6 and C equals 10, then what is A when B equals 2 and C equals 15? Okay, so let's get started. We're going to use our definition of joint proportion. So if A is jointly proportional to B and C, then A over BC is constant. What is A over BC? Well, we're given A equals 5 when B equals 6 and C equals 10. Which is 5 over 60, and that's just 1 over 12. We need to find the new A now when B equals 2 and C equals 15. So once again, since A is jointly proportional to B and C, A over BC is equal to, we need to find the new A, B equals 2 when C equals 15, and this has to equal 1 over 12. So let's multiply both sides by 2 times 15, because now we just have this equation to solve. And we'll get a is equal to 30 over 12, which simplifies to 5 over 2. So there's our answer. Let's go ahead and box that. And there we go. And in fact, I actually forgot one thing over here, so I'm just going to go back. In case you're a little confused about this part, x is directly proportional to both y and z. Let's take a look over here. So we have an x on the top and a y on the bottom. I want you to just ignore the z for now. So there's the first direct proportion relationship, x over y. If you don't remember that, go ahead and review the video I did on direct proportion. And then if we just ignore the y, let's just look at x over z. X is directly proportional to z. So you can see there's two parts. There's like an x over y, and then there's this x over z, just to clarify things. Okay, that was the first problem with direct proportion. Let's move on to the next one. I think you'll notice that the next problem will be very useful in life. I guess it may come up, not sure, but I'm sure it has its uses. And just as a sneak peek, here it is. So that's the problem if you want to give it a try, but I'm going to go over it in the next video. So yeah, I'll see you there.